Today we're going to talk about conditional probability, but to understand that we first have to make sure we have some of our vocabulary down. So I suspect many of you have seen this before, but we're going to talk quickly about unions and intersections of sets. Okay, so I've written down two sets that we could consider. Set E1, which will change into E2 for a quick example later, and F1, which will eventually become F2, where are these sets, the counting numbers from 1 to 10 and the counting numbers from 11 to 20. So we could first of all represent this with a diagram. I could draw a box, and the box could be counting numbers from 1 to 20. And we could literally divide the box in half, and we could put set E1 over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we could put E2, or I'm sorry, F1 over here, which is 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay, now if we want to talk about the union of sets, we need to look at E, and then this symbol right here is the union symbol. So actually this is E1, F1. So if we want to look at the union of those, it means we're counting everything that's in E1. The English word that we could put in here is or if it's in F1. So we count it if it's in E1 or if it's in F1. So what would this be? This would be the set of numbers 1, 2, 3, 4, all the way up to 17, 18, 19, and 20. In other words, it would be all of them. So it would be all the numbers and none of them twice. So an important thing is none repeated because there is no overlap here. Okay, so we wouldn't count something twice when we're looking at the union of these two sets. So if a number is in E1 or it's in F1, it is in the set E1 union F1. Now, if we turn around and look at the intersection, we use this upside down U for the intersection. So to be in the intersection of two sets, it's not going to make as much sense in this example. It'll make more sense in the future examples. You're really thinking about an and statement. For something to count, it has to be in E1 and it has to be in F1. All right, and you can see there are no numbers that are in both E1 and F1. So we designate this as the empty set. Sometimes you might see a 0 with a line through it, the null set. Sometimes that's called the null set, meaning there is nothing in it. Okay, now let me quickly make another example. Okay, so we have the same set E1 as before, but now we have a set E2, which is only the odd counting numbers from 1 to 19. So we want to look at what this will look like. Okay, so first visually, let's make this, put this in blue. All right, so let's start with our box, okay, which was all of the counting numbers from 1 to 20, right? Now, inside of that box, we're going to want to have some subsets, right? We will have some numbers that are in E1, numbers from 1 to 10. We'll have other numbers that are in F2, and we will have numbers that are in both. All right, so let's just start counting. If we look at 1 is in both because it's an odd number. 1 is actually in set E1 and it's in set E2. If we look at the number 2, it's in set E1 but not E2. 3 is in both. 4 is in E1, 5 is in both, 6 is over here, 7 is in both, 8 is over here, 9 is in both, 10 is in E1. Now we get to 11. Okay, it's an odd number, but it's not between 1 and 10. So we have to put it in the loop. I'm sorry, this is not E2, this is F2. It's included in F2. It is an odd number, an odd counting number from 1 to 19, but it is not between 1 and 10. So we only put it in the bubble for F2. Then we get to the number 12. Well, that doesn't fit in either bubble, so we have to put it outside of both bubbles. And then we get to 13, that's back in F2. 14 is outside of both. 15 is back in F2. 16 is outside of both. 17 is in F2. 18 is outside of both. And 19 is in F2. Okay, so now we can talk about the union of E1 union F2, and this will be a set. So remember, we count things that are in either one of the bubbles. All right, so if we look at that, the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 are all there because they're in E1. Some of them are also in F2. I'm going to put dot, dot, dot and come down here. But then we have the numbers 11, 13, 15, 17, and 19 that are in F2, but not F1. So the key is some numbers showed up twice. Let me underline them. But when we write out the union, we only count things once. We're just looking at all of the elements that are out there, and we're going to pick everything that is in E1 or F2. Now, if I want to find the intersection, here's the symbol for that. Now we only count things that are in E1 and F2. They must be in both. So the elements that are in both are 1, 3, 5, 7, and 9. Those are in both. So those are in the intersection. So this was the union, counting if they're in either, and this is the intersection. And you can see when you use the Venn diagram, why we call that an intersection. It's where the two groups overlap or intersect, right? So let's quickly look at one more example. Okay, so in this example, we keep the same F2, but we've changed E to, set E to include all the numbers from 1 to 20. So let's first draw it. So we could use a box, or I could draw, let's hold on one second. See if this is going to let me draw. Oh, I'm still in the text area. So let me come down here. So I could just make a big E2, right? Now, where is F2? F2 in this case is completely inside of E2. So if we start counting from 1 to 20, we can see that if we start with the number 1, that is in F2. It's also in E2. The number 2 is over in E2, but not F2. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and I just have barely enough room. I'll stick 20 down there. And you can see that all of these numbers from 1 to 20 are inside of E2, but they're not inside of F2. So we can say F2 is a subset of E2. Okay, now this does something interesting with the union and intersection. So if we look at E2 union F2, since F2 is inside of E2, if you simply need the union, you can say it is equal to E2. Because if it's in F2, it was already in E2. So in other words, the union is the whole set. All right, now if we look at the intersection, E2 intersect F2, it would simply equal F2. Because in order to be in both E2 and F2, you're required to be in F2 because of the way F2 is inside of E2. So when we have one set being a subset of another, the unions and intersections are slightly different than when you have things that are overlapping. So the second example is sort of the classic example that we think of most often, but we should realize that in the first example, we could have two sets that don't overlap at all. We have in the second example, two sets that partially overlap. And then when we get to our third example, the two sets, one set is inside of the other set, making it a subset of the first set.